Video 9. Importing image data into NumPy arrays. In the previous video we learned cleaning up data from outliers. In this video we're going to look at image data importing using NumPy. We're going to demonstrate how to do image processing using Python's libraries such as NumPy and SciPy. In scientific computing, images are usually seen as n-dimensional arrays. They're usually two-dimensional arrays. In our examples they are represented as a NumPy array data structure. Therefore, functions and operations performed on those structures are seen as matrix operations. Images in this sense are not always two-dimensional. For medical or biosciences, images are data structures of higher dimensions, such as 3D, having the z-axis as depth or as the time axis, or 4D, having three spatial dimensions and a temporal one as a fourth dimension. In this video, we'll not be using those. We'll demonstrate several ways to use image processing in Python, mainly related to scientific processing and less on the artistic side of image manipulation. In some examples, we use the SciPy library, which you have already installed if you have installed NumPy. If you haven't, it's easily installable using your OS's package manager by executing the following command. For Windows users, we recommend using the pre-packaged Python environments like EPD, which we discussed in preparing your working environment. If you want to install these using official source distributions, make sure you have installed system dependencies such as BLAS and LAPACK, lib-BLAS and lib-LAPACK, C and Fortran compilers, GCC and G-Fortran. Whoever has worked in the field of digital signal processing or even attended a university course on this or a related subject must have come across Lena's image, the de facto standard image used for demonstrating image processing algorithms. SciPy contains this image already packed inside the MISC module, so it's really simple for us to reuse that image. This is the code to show the image. We're using the ascent function as the Lena function doesn't run in Python 3.5. So this is the image. It's in grey tones and axes. The colour bar shows a range of values in the figure. Here it shows 0 as black to 240, which is white. If you use the Lena function, the image will be different. Further, we could examine this object with the following code. Let's run the code and see the output. We see the following features in the image. It's 512 points wide and 512 points high. The max value in the whole array, that is the image, is 255. Every point is represented as a little endian 32-bit long integer. We could also read in an image using Python library imaging, PIL, which we installed in section 1, preparing your working environment. Here's the code to do that. Let's run the code. Okay, this is similar to Lena's image. This is useful if we're already tapping into an existing system that uses PIL as their default image loader. Other than just loading the images, what we really want to do is use Python to manipulate images and process them. For example, we want to be able to load a real image that consists of RGB channels, convert that into one channel, ND array, and later use array slicing to also zoom into part of the image. Here's the code to demonstrate how we're able to use NumPy and matplotlib to do that. Bug::0 is called array slicing. This NumPy feature allows us to select any part of the multi-dimensional array. For example, let's see a one-dimensional array. Have a look at the following code. Here we zoom into the particular portion of the whole image. Remember that the image is just a multi-dimensional array represented as a NumPy array. Zooming here means selecting a range of rows and columns from this matrix. So we select a partial matrix from rows 100 to 250 and columns 140 to 350. Remember that indexing starts at 0, so the row at coordinate 100 is the 101st row. Take a look at the following code. This will be displayed as shown here. For large images, we recommend using numpy.memmap for memory mapping of images. This will speed up manipulating the image data. Have a look at the following code as an example of this. Here we load part of a large file into memory, accessing it as a NumPy array. This is very efficient and allows us to manipulate file data structures as standard NumPy arrays without loading everything into memory. This argument shape defines the shape of the array loaded from the file_name argument, which is a file-like object. Note that this is a concept similar to Python's mmap argument, available at docs.python.org, but it's different in a very important way. NumPy's memmap attribute returns an array-like object, while Python's mmap returns a file-like object. So the way we use them is very different, yet very natural in each environment. There are some specialized packages that just focus on image processing, like scikit-image, available at scikit-image.org. This is basically a free collection of algorithms for image processing built on top of NumPy/SciPy libraries. If you want to do edge detection, remove noise from an image, or find contours, scikit is a tool to use to look for algorithms. The best way to start is to look at the example gallery and find the example image and code, available at scikit-image.org. In this video, we've learned how to import image data into NumPy arrays. Awesome! In the next video, we'll take a look at generating controlled random datasets.